Hi, everybody. I'm going to get started. So we have today and tomorrow are the last two live classes. There's not going to be any on Wednesday or Thursday. I want to give you opportunity to work on your project. Now, we up until now we've done Babylonian math, Egyptian math, Chinese math, and Greek math. And we made it from about 1600 BC until Archimedes is 250 BC. And now we're going to fast forward through a lot of centuries. But before we do, I just want to quickly mention that Archimedes, this is more like a list of just stuff, not going to have specific like mathematical proofs here. I just want to tell you Archimedes. So Archimedes was around 250 BC. And Archimedes' biggest or most famous accomplishment is Archimedes is the one that came up with the approximation for pi that we still use today, 22/7. In one of his famous little treatises that he wrote, he proved that pi is a little bit less than 22/7. He showed that pi had to be between 3 1/7 and 3 and 10/71. Notice how 10/71, 10/70 would equal 1/7. So 10/71 is a little bit less than 3 1/7. And in one of Archimedes' most famous treatises that he wrote, he proved this. Archimedes is also the one that proved that came up with the formulas for the volume and the surface area of a sphere. The volume is 4/3 pi r cubed, and the surface area is 4 pi r squared. Those are formulas that we still, teach sometimes in middle school, just to say here's two formulas, but it was Archimedes that came up with those. And Archimedes is generally considered to be one of the top 3 mathematicians of all time. Although the thing he's most famous for is discovering the law of buoyancy and helping a king who wanted to know if a crown, he gave a jeweler a certain amount of gold to make a crown, and he suspected that the jeweler had mixed in some other metals and kept some of the gold. And Archimedes, while bathing, figured out that if you put the crown in water, it will make a certain amount of water move up, and if it's all gold, it will make a predictable amount of water rise. But if it's part gold and part silver or part some other metal, it will make a different amount. And that's where he ran around the town screaming "Eureka," which is a very famous word still. Eureka means I have found it in Greek. So that's all I want to say about Archimedes. He's one of the big 3 of all time. So what happened between 250 BC and 1545 AD in these almost 2,000 years? Well, Greece got taken over by Rome, and the Romans were not like that interested in math and a lot of these intellectual pursuits like philosophy. So they burned the library of Alexandria, which had all these mathematical works in them. Fortunately, now remember, in Babylonia, those were people from the Arab world. Well, fortunately, in that area, the Middle East, they had gone to Alexandria and they had made copies of some, but not all, of the books in the Library of Alexandria. Definitely Archimedes' books they had copied, but they copied Euclid's Elements and the best of the works. But like 90% of the Library of Alexandria was just burned, and with that, the only existing copies of 90% of that stuff were lost forever. But fortunately, people from the Arab world had made copies of so many things and translated it into Arabic. And that's why the center of math became in the Arabic world, where they advanced things like trigonometry and algebra. In fact, the word algebra is Arabic. It comes from an Arabic word. And but we're not doing the Arab mathematicians. Just if we had just another 5 days of the course, then I would put into this part right now the Arab mathematicians like Al-Khwarizmi, who the word algorithm comes from. So a lot of math. The center of math basically went to the Middle East. But then, in the year 1202 AD, someone named Fibonacci visited the Middle East and learned their math and came back to the West, Europe that is, and wrote a famous book called the Liber Abaci. And in that book, he introduces the Western world, Italy that is, to the techniques that were cultivated in the Middle East. The base 10 number system and algebra. And this very influential came out. And from 1202 on, math came back to the Western world. So yes, in 250 BC with Greece, math was in the Western world. But for these 1,500 years, math had gone to the Middle East. And then it came back to the West in the year 1202. And then from 1202 until like the 1800s, for the next 600 years, Europe was really the center of math research, development of math techniques. So 1202, you had Fibonacci, and we're going to, in today's lesson, see what happens in the 1500s and what's so special about 1545 AD. Okay, so that sort of takes us from where we were, the Greeks, to where we want to be today with Italy and the mid-1500s. Because quadratic equations were mastered or solved, at least. Quadratic equations were solved in BC times. Babylonians answered questions, like x plus y equals 10, x times y equals 16. So those are basically quadratic equations. The quadratic formula was well known eventually. And this is a thing we memorize in high school and even in middle school. So the quadratic formula, maybe not in this form, but the ability to solve quadratic equations was like 1600 BC. Now, the next logical step is, so that's for solving questions like ax squared plus bx plus c equals 0. But what about equations like ax cubed plus bx squared plus cx plus d equals 0. Well, people weren't that interested in that question for a long time, but in the 1500s, mathematicians in Europe became very interested in that question. And was there a general way to solve a cubic equation? And that became like the thing. The race was on for that. And let me tell you a couple of, oops, I'll show you this. Certainly don't want to write this down. Don't. But there is actually a cubic formula, which looks like this. There's 3 answers, so they haven't split up, but this monstrosity is the cubic formula. We're never going to use this formula, but we are going to learn how to solve cubic equations with a process that's equivalent to using that formula. Here's a timeline. Just before 1500, an Italian mathematician declared in a book that there's never going to be a cubic equation. That mathematician's name was Pacioli. He was actually a good friend of Leonardo da Vinci's. He said we're never going to solve it. But he was wrong. And 20 years later, the first progress towards the cubic equation was made, where a mathematician named Del Ferro figured out how to solve equations if they were in this form, like x cubed equals 6x plus 40. That cubic equation has no x squared term. And when there's no x squared term, it's officially called a depressed cubic. And Del Ferro figured out a formula for solving equations like that, where you could just plug in the 6 and the 40, and out comes one of the 3 solutions. And all I cared about was getting one solution, the positive answer. Now, Del Ferro, back in those days, you didn't just publish your solutions, because someone else from another country would they would steal it and say they made it. And by the time anyone figured out what happened, that person might have credit for it. It's not like today where you can publish something and get priority in publishing something. So Del Ferro kept his process for the depressed cubic secret. And back in those days, what you would do with the secret formula, they would have these mathematical contests where 2 mathematicians would come to like a room, and they would each give each other 10 problems to do that they knew how to do, and then they would come back a week later, and whoever solved more of the other person's problems was declared the winner of the contest. So rather than publish the x cubed equals fx plus g formula, he keeps it secret and uses it to win all these challenges, because no one else knows how to do that question. Now, Del Ferro died and passed on the secret to this sort of equation to his student, whose name was Antonio Flor. And Flor would use this formula to challenge people until he challenged someone named Tartaglia. Now, Tartaglia was making progress on cubic equations himself. And even though Tartaglia never figured out how to do this kind of cubic equation, he did figure out how to do this kind. It's another type of depressed cubic. It has no x term, but it has an x squared term. So Tartaglia gives Flor 10 questions of this type to solve. Flor gives Tartaglia 10 questions of this type to solve. And if you know there's a formula and you know that someone knows it, it makes it easier sometimes. But whatever it is, Tartaglia figures out how to do these questions. So now Tartaglia knows how to do both of these types of depressed cubics, and floor disappears into obscurity because he can't really do anything except what Del Ferro told him. But Tartaglia does not publish these formulas because he knows that it's probably not going to be too long until he figures out how to solve cubics that have all the terms in them. That's kind of like the holy grail of math at this time. And Tartaglia has made progress on it because he's figured out how to do two different types, but he doesn't know how to do the kind that has all the terms. And he works on it. For 13 years, he's working on it. And this is where the next character comes in to play, someone named Cardano. And Cardano is very famous because the formulas for the cubic equations are called Cardano's formulas now. Cardano begs Tartaglia to tell him how to do the cubics that he knows how to do already. And Tartaglia agrees, but only if Cardano promises to keep it a secret. Well, Cardano, for the next 6 years, works on trying to do the general cubic equation. And he accomplishes it. But he's not allowed to publish it because it relies on this formula, which Tartaglia told him. But then Cardano gets an idea. He says, what if I go back? Because Tartaglia is not the only person who knows this formula. Flor knows it, but Del Ferro, well, he's dead. But Del Ferro had a widow. So Cardano goes to Del Ferro's widow and asks if he could look at Del Ferro's papers. And in those papers, he finds the solution to the depressed cubic, this type. And then Cardano feels like he can go ahead and write his book. And that's why 1545 is an important date in the history of math. Cardano publishes Ars Magna, which means the great art, in which he explains how to solve cubic equations. And he gives Tartaglia credit, but he also says, we got it from Del Ferro. So Tartaglia was not happy about this. But, it's true that Tartaglia did not invent this. Del Ferro was the first one, so he kind of couldn't keep it a secret. Ars Magna, 1545. So now you're wondering, what is this? What's that? That's weird. Oh, I'm not liking this. Okay. Well, the rest of this lesson, I'm going to teach you how to solve cubic equations. I'm going to start with an unusual way of solving a quadratic equation. X squared plus 10x minus 21. Now, type into the chat, what are the main 3 ways that you know of solving quadratic equations? Yes, I see completing the square, trinomial, like factoring, and the quadratic formula. Those are the 3 ways that you learn and that we teach in high school. The box method is like a way of factoring also. Well, I'm going to show you another method. And this method seems really strange. What if I were to replace x with something. Oh, and by the way, the two answers to this question using, this one actually factors, x minus 7, x minus 3. So the two answers are x equals 7 or x equals 6, just kind of, so we can see if this new method gets us the same answers. What if I would replace x with y plus 1? Well, now it would turn into y plus 1 squared equals 10 times y plus 1. And let's say I don't know how to factor, and I don't know how to complete the square, and I don't know how to, oh, thanks for pointing that out. Is that not what my question is? Should it be plus 21? Hold on a second. Sorry about that. Ah, thank you. Thanks for noticing that. It's minus 10x plus 21. Sorry about that. Okay, let's change this to a minus also. So this, if I replace x with y plus 1, if I just, or anything, replace it with y plus 2 or y plus something or y minus something, what I end up with is a new equation that has y instead of x. And now let's say I know how to do FOIL. Y squared plus 2y plus 1 minus 10y minus 10 minus 21 equals 0. And now I combine like terms. Oh, did I make a mistake here? 1 minus 10
plus 21.
9. Oh, yes, thank you. That's plus 21. So this is going to be 1 minus 10 is negative 9, plus 21 is plus 12. So I've turned this equation into this equation. Well, you say, what good is that? That's just another equation. That's just as hard as the original. So that doesn't seem very useful. Like if I don't know how to factor, and I don't know how to use the quadratic formula, and I don't know how to do completing the square, what good is it to solve this equation when I don't know how to do this one or this one? So this seems very strange of a technique. And that's because y plus 1 is not the best thing to replace x with. The best thing to replace x with is y minus b over 2a. A is 1, b is negative 10, c is 21. This is in our like ax squared plus bx plus c equals 0. So in this case, it's y minus negative 10 over 2, which is y plus 5. So if I replace x with y plus 5, I get this equation. Would you, now this looks just as, again, looks like the same thing as before. How is that any easier than this? Well, would you take a minute and actually simplify this y plus 5 squared minus 10 times y plus 5 plus 21 equals 0 and watch what happens? Everyone take a few minutes to do their simplifying. Okay, good. So what I'm noticing, and you'll want to remember the sort of mathematical like background you want to remember is that when you square something like x plus a squared, you get x squared plus 2ax plus a squared always. So this is y squared plus 10y plus 25. And when I distribute this 10 through, it's not a 10, it's a negative 10, so be careful. It's minus 10y. Don't forget, most common error in high school math, minus 50, not plus. So make sure you have that minus 50 there. Now something very fortunate happens. When I combine like terms, the negative 10y's cancel out. I end up with y squared. 25 minus 50 is negative 25 plus 21 is negative 4 equals 0. Now this equation is definitely easier than the original equation. Even if you don't, you could do difference of squares, that's true. But even better than that is y squared equals 4 and y equals plus or minus 2. So even if you know nothing about factoring, and even if you don't know the difference of squares, you would be able to solve for y. Well, that's all great, except the original question, wasn't asking about y. The original question was asking about x. Well, I want you to compare these two things. And here's one of the most important thought-provoking questions. If y equals 2 makes this equation true, which it does, what number for x would have to make this equation true? What do you think of that? So this is kind of a hard concept, but if 2 makes the y equation true, which it does, because that whole y squared minus 4 is equivalent to that complicated y plus 5 squared plus 10 times y plus 5 and all that. That's a good question. How does it help us with x? Because if I put 2 in for y, the y plus 5 turns into 7. And this turns into 7 squared minus 10 times 7 plus 21. But notice how much that looks like this. So here's the question again. If 2 makes this equation true, if 2 for y makes this equation true, what should make, and yes, the answer is 7. Remember here, it says x equals y plus 5. So if you take each of the answers that makes y true, which 2, for instance, 2 plus 5 is 7. And while we're at it, negative 2 makes this negative 2 makes this equation true. But this equation and this one are the same. One was just simplified. So negative 2 plus 5 is the other solution. And that equals 3. And remember, 7 and 3 were the answers to this question originally. So this is a kind of unusual way of solving a quadratic equation. But if you replace x with y minus b over 2a, and then you simplify, the new equation will always be that there won't be any linear term. In this case, it became y squared minus 4. In other words, this will always happen. That wasn't a coincidence. That's got to happen when I plug this in. That forces this to happen. So it turns this quadratic equation that maybe I don't know how to solve into this quadratic equation that I do know how to solve. And then I just have to adjust my answers and I get the answer to the original equation. So that's a very involved trick. And you're not going to want to use that for solving quadratics unless on the homework I say, solve a quadratic this way. Maybe for practice, we should do one. x squared minus 6x. Would you go ahead and take a minute to try to go through this process where you eventually will end up with y squared equals something, which will lead us to two y answers, which will then lead us to two x answers. Okay, so take a minute on that. Okay, and if you look up at the screen, you can see that by substituting x equals y plus 3, it becomes this equation. Simplified becomes this equation. Simplified more becomes this equation, which has two very easy answers, but that's for y. X is y plus 3, so if you add 3 to the two answers, you get 4 and 2, which are the two answers to the original equation. Now, this is an odd way to solve quadratics, and we'll probably never use it to solve quadratic, but it's going to be important for what's coming. Now, here is a cubic equation. So this is your first ever cubic equation. And solving a cubic equation is very difficult. There's a reason why it took thousands of years between the solution of the quadratic in 1600 BC and the solution to the cubic in 1545 AD. Before we tackle cubic equations, we'll come back to this one. We're going to look at, Hold on a second, that's strange. Where's all my examples? Everyone hold on for a second. Okay, I'm back. By the way, just as a reminder, some cubics aren't that hard. Does anyone know? Maybe they teach it. Yes, I see that. Factor. I saw the words factor by grouping. This cubic is special because if I factor x squared out of the first two terms and I factor -1 out of the other two terms, just by total luck, really, if this thing happens to match with that, then you're able to factor that out. And then you can maybe even factor the x squared minus 1. I just want to mention this. This isn't related to what I'm going to teach you. I'm going to teach you ones that can't be solved by this method, but I did want to mention because some of you might be algebra teachers, and there are some cubics that are easier than others. But my lesson today is starting with what are called depressed cubics. Specifically, depressed cubics that are of this form: x cubed equals something x plus something. The answer is an integer. Anyone want to just mess around with the numbers and maybe you just come up with it just by trial and error? Is it 3? 3 cubes, 27. 9 times 3 is 27. So that's 28. But 4 does work because 4 cubes is 64. And 9 times 4 is 36 plus 28 is also 64. So 4 is the answer. So whatever process we do, it better give us an answer of 4 for this question. I am going to first show you the formula without any explanation of why it works first. I just want you to see the famous formula. It's going to be very mysterious formula, but it's actually easy to do. So here's the process. Step 1, take the constant number and divide it by 2. Step 2, square the 14. Step 3, by the way, it's always divided by 2 there. Step 3 is to take the other number, the coefficient of the x, and always divide it by 3, and then raise that answer to the 3rd power. So there's only one more step, believe it or not, but these are step 1, step 2, and step 3. Again, I haven't explained where this comes from. And then step 4 is to assemble these 3 numbers into an answer. But that answer is going to look like this always. And there's 4 blanks to fill in. And the first and third blanks are this number, the 14. And the second and fourth blanks, if you subtract these two numbers, 196 minus 27, that's what goes here. Yeah. Maybe I should call this step 5 and call step 4 196 minus 27. That's the formula. That's the what's called depressed cubic formula, or that's it's like a formula. Now sometimes we have to stop at this point. Sometimes we can't go any further because this 169, it didn't have to be a perfect square, but in this example 169 does happen to be a perfect square. That's very unusual, actually. And we could even go further now, because 14 plus 13 is 27, and 14 minus 13 is 1. And look at how lucky we are. 27 is a perfect cube, and so is 1. And I get 3 plus 1 is 4. Yeah, this process is going to be when factor by grouping doesn't work. Although this doesn't have an x squared term, this process only works if it's x cubed equals something x plus something, but we'll get to the other type afterwards. I'm going to leave this on the screen. I'm going to put up a question for you to do. Could you please try to use the same process for the equation x cubed equals 6x plus 40? And if this number here doesn't turn out to be a perfect square, that's fine. You could just leave the answer as step 5. So step 6 is optional to simplify if possible. Anyway, please do x cubed equals 6x plus 40.
Could you write that equation somewhere? I didn't catch it.
Do you mean the x cubed equals 6x plus 40, or do you mean the formula for solving it?
My apologies. I didn't see it. Thank you.
Okay. If the thing inside the square root doesn't simplify, you just leave it as that big, ugly looking answer.
Weren't we supposed to divide 6 times 3, not by 2?
You're right. Sorry about that. It is 6 divided by 3 cubed is 8.
Oh, okay.
So you get this very ugly answer. Cube root of 20 plus square root of 392 plus cube root of 20 minus square root of 392. And you can't simplify it. What's kind of funny is that if you were to put that complicated expression into a calculator,
It wouldn't be 392 because it wouldn't be 8, it would be 27, but it'd still be an ugly answer. It'd be 373.
wait, 6 over 3 is 2 though. 6 over 3 cubed is 8. So I made a mistake when I had the 2 there, but
Okay, right, okay, so I took it even further.
check out what happens when I push enter.
Okay.
That big mess, you probably figure some kind of irrational mess, but it's 4. And if you look at the original question, you could see that by trial and error, x cubed equals 6x plus 40. Well, 4 cubed is 64. And 6 times 4 plus 40 is also 64. So it's kind of weird about this that there's actually no way to simplify or no easy way to simplify this. So you really wouldn't know. Sometimes you get lucky and it's a nice answer like before and it simplifies. But this one actually has a nice answer of 4. But when I run it through the formula, I get this very ugly version of 4. And that's okay. You would leave it like on a test or whatever. If this 392 didn't simplify at all, you just leave it like this. You wouldn't even know that it actually was an ugly way of saying 4. Now, in the videos for the class, I derive this formula. Why don't I write it down as a formula just so that you have it? So the formula would be if x cubed equals px plus q, the formula would be cube root of q over 2 plus the square root of q over 2 squared minus p over 3 cubed plus that same thing with a minus here. I don't really think of memorizing this formula personally. I just do the process where I divide this by 2 and square it, divide this by 3 and cube it, and subtract those 2 numbers. But I'm not going to show this class. I'm just going to refer you to a video that I made that I posted already that kind of shows you where this formula comes from. I just want you to know how to do the questions with the formula. So this formula was the big deal that took 3,000 years for someone to figure out and took another 30 years to get published. But now you're wondering, oh, okay, so we did those. Oh, did I find my equations again? Quadratic. Where's that cubic that I put up before? Hold on. That's okay. Let me come over here. Okay, so now you're wondering, what if, hold on a second, I just wanted to do a good example. Here's a complete cubic now, our first one ever. hold on, x cubed plus 6x squared okay, so that is a cubic that has all the terms in it. But we don't have a formula for that. We have a formula for a depressed cubic. Does anyone have a thought about what the next step might be? I know how to do depressed cubics now. I don't know how to do this type. Remember before the person who didn't know how to solve quadratics, but they didn't know how to solve like x squared or y squared equals 1. They have no problem with that, but they have trouble with like x squared minus 5x plus whatever. The step is to replace x with y minus, remember before it was b over 2a? Well, this time it's b over 3a. That's the big secret thing that took 30 years for someone to figure out. And again, not a lot of people were looking for it, but watch what happens. If I replace x with y minus 2. Now I'm going to cheat for a second, and I'll let you verify your answer with this also. I'm going to go back to the, I'm going to go onto the web now and bring up a website that's called Wolfram Alpha. Now, of course, I could take Wolfram, if I have Wolfram Alpha, it's like the ultimate graphing calculator. I can take the equation itself and it will just solve it for me, right? What does it get? It says x equals 1 is the answer. Well, that's really cheating. Instead, I'm going to say simplify. If I replace all the x's with y minus 2, so y minus 2 cubed plus 6 times y minus 2 squared plus 6 times y minus 2 minus 13. And don't say equals 0. And when I do that, you see over here, it's turned into y cubed minus 6y minus 9. You use y minus 2 because if you do y minus b over 3a and substitute in, it will always turn into, see how there's no y squared term here? It will always, the y equation will always be a so-called depressed cubic. Let me come back over here to the iPad. Oh, someone's trying to get in. Here we go. Okay, so let me come back over here. I'm going to write down y minus 2 cubed plus 6 times y minus 2 squared plus 6 times y minus 2 minus 13 equals 0. That turns into y cubed minus 6y minus 9 equals 0. Now you might say, well, what if I don't have Wolfram Alpha? Well, let me just take you through. Remember how a plus b is a squared plus 2ab plus b squared? Well, a plus b cubed, if I multiply this whole thing times a plus b, I would end up with a cubed plus 3a squared b plus 3ab squared plus b cubed. And this is sort of worth remembering. So if you're wondering like y minus 2 cubed, that would be y cubed plus 3 times y squared times minus 2 plus 3 times y times minus 2 squared plus minus 2 cubed, which is y cubed minus 6y squared plus 12y minus 8. And if I come back over here and look at what's 6 times y minus 2 squared, would be 6 times y squared minus 4y plus 4, which would be 6y squared minus 24y plus 24. So notice that this does this have a plus here? Yeah, it does. Notice how the minus 6y squared and the plus 6y squared would end up canceling out. Anyway, back to here. This is now a depressed cubic, which I can move over to get 6y plus 9. And this, I can run through the formula. It's a little annoying because I would have to have 9 over 2, which is 4.5. So it looks like this is going to be one of those that doesn't work out nicely. But 4.5 squared minus 2 cubed is 20.25 minus 8 is 12.25. This is looking like ugly. That's cube root, by the way. 4.5 minus the square root of 12.25. As ugly as these look, though, the square root of 12.25 is actually 3.5. And 4.5 plus 3.5 is 8. And the cube root of 8 is 2. And over here, 4.5 minus 3.5 is 1, and the cube root of 1 is 1. So we end up with y is 2 plus 1, which is 3. But 3 is the answer for y. What's the answer for x? Yes, it is 1, because remember back here, x is y minus 2, so it's 3 minus 2 equals 1. Okay, and now I'm going to give you a question. I'm going to put you into groups to try, and you could use Wolfram Alpha to get the expression. Oh, by the way, I just want to mention that if this thing didn't simplify so nicely, y would have to be left, and there's a really ugly answer, and then x would have to be that really ugly answer minus 2, and you'd have to leave it like that. Well, I'm going to put you into groups. Before I do, here's the question for you to work on with your group. X cubed plus 15x squared minus 36x minus 450 equals 0. You figure out what eventually you should get y cubed equals something y plus something, which you'll then get a really ugly answer for y, which will not be able to be simplified. And your x answer is going to be pretty ugly also. There's going to be an extra, something over here. So make sure you have the question. I'm going to put you into groups for about 15 minutes. You can use Wolfram Alpha to do the simplifying, and you can get this answer, which again will be really ugly looking, but it will be correct. Okay, let's see, breakout rooms. Oh, let me pause there. Okay, everybody, let me go back to the screen share. So I made a mistake. I don't know how this happened, but I think that the 36 was supposed to be a 27. So I'm just going to show you what was supposed to have happened. And again, I don't know why this happened, but here's what happened for you. Because I made some kind of mistake, like this number was supposed to be maybe a 27 instead. And if that was right, I don't know what happened. This was going to turn into 39y plus 388, plus 380, I mean. But unfortunately, I had a 36 here, which you say, well, no problem. I'll just do 111. 111 is not so, what's so bad about these numbers? It's just two other numbers. But what you might have found is when you started to do the Cardano thing, you would get 10 plus, you get the cube root of 10 plus the square root of 100. That's 20 over 2 squared minus 111 over 3 is 37. And 37 squared became 1369. And we end up with a negative inside. And Cardano would have said, don't just abandon ship at this point, because he didn't know how to deal with negative square roots. Although the truth is, now that we do know how to deal with negative square roots with I and everything, this process actually still does work. But I made a mistake.
But is it squared?
No.
The cube, because you told us cube, but right now you said squared, so now I'm confused.
Oh, sorry, even worse, right? 111 over 3, so it's 50,000 something. So it's even more negative. So would you in your notes just change this to a, oh wait, that's a, I'm confused. Wait, y minus 5. Let me just go, and I definitely, that other one's not right either. Hold on. Let me go to my Wolfram Alpha page again. And what I meant to do, let me just see what happens. I put a 5 here. I'm doing sort of the process in reverse. If x is y minus 5, then y is x plus 5. And if I take that equation, this is what was meant to be the equation. Let's see what it becomes. What's the difference there? 15x squared, 36. Isn't that what it was? Oh, it's plus 36x. Okay, so the mistake I made was not that it was supposed to be 27. The mistake I made is this was supposed to be plus, and that was going to change our equation. That's a bad typo. I have to make sure in my video I didn't make that same mistake. That would turn the equation into y cubed equals 39y plus 380. And that would have turned into cube root of 190 plus the square root of 33903 plus the cube root of 190 minus the square root of 33903. Those things are not negative like they were when I accidentally had this plus here instead of a minus, or minus instead of a plus. And this thing does not simplify. Oops.
Excuse me, sir, you're still on Wolfram Alpha.
Here you go. Let me go back to that. Here you go. So sorry about that negative sign. This is what would have ended up happening. This thing would not be negative, but it also wouldn't be a perfect square. It's about 9.0098. And then x would be this ugly expression minus 5. So I would just have to, so the answer would just look like this. This ugly mess, 190 plus square root of 33903 plus the cube root of 190 minus the square root of 33903. And then the minus 5 is there at the end. Just so you know, that's about 4.0098, but there's no real easy way of simplifying that. So on your homework, if you find this thing's not a perfect square, you can just leave your answer as this ugly mess. But the minus 5 does need to be there at the end. Well, I'm sorry about that wrong sign.
What do you mean the -5 needs to be there at the end?
Oh, because the question was about x, and x was y minus 5, and this ugly answer is what y equals.
Got it.
But we have to subtract 5 at the end. So there's nowhere to put the 5 except just stick it at the end like that, and that's the exact answer.
Can we put parentheses around the cube roots and then the -5 outside of it? Would that work too?
Oh, sure. Yeah, you want to go like that? You can.
Yeah, right, exactly.
Yeah, because otherwise you might think the 5 is like inside one of the, one of the square roots. So that is fine.
I'm sorry, wait, so the -5, but we haven't had a number like that before, so I'm sorry, I lost where that came from.
The -5?
Yeah,
Well, this thing here that I'm about to highlight, that thing is the answer to the y equation. This thing is the answer to this equation. Now that equation is the same thing as this equation, but it's not this thing. That thing is different because the substitution was that x equals y minus 5. So whatever you get for y as your answer here, that big mess, x is not that, it's that with a -5 at the end. If you go back to when we did the quadratic equation that way, where we like replaced x with y minus 2 or whatever, and we solved for y, and at the very end, we adjusted, it's the same thing. The only difference is our y value was real ugly. So our x value is the real ugly y value -5. As ugly as that y value is, it's a number. It's a little bigger than 9. So a number a little bigger than 9 makes this equation true, which also makes this equation true. But it doesn't make this equation, sorry. It also makes this equation true, sorry, that number a little bigger than 9. But since 9 minus 5 is 4 point something, that's why this equation's answer is not 9 minus 5, but it's not 9, but it's 9 minus 5. But it's not really 9. It's this extremely complicated expression, which is about 9 minus 5. Christine, were you asking about the 33903?
Yes, I do. I don't understand it.
Yeah, 33903 came from doing 380 over 2 squared minus 39 over 3.
Oh, okay.
That's where 3903 came from.
Okay, thank you so much.
Back in the step of solving the depressed are all over the place now. By the way, remember the scary general cubic formula I showed you before? Look at it now. You can kind of see this minus b over 3a. That's kind of like the -5 that went after it. And you can see this expression here resembles what you get when you do the Cardano formula, except they have an a involved, so it kind of makes this look really ugly. Now, I did make a nice video about this. I do need to go back and change that minus into a plus. I might have to remake that video, which took a long time to make. Oh, well. Okay, well, that's what I wanted to show you today. Why don't I bring up the homework? A lot of people like to, before I go, just kind of like glance at what the homework is so that you can feel like, okay, this homework's not going to take like so long. let's see.
Also, Professor, when I go to Wolfram Alpha, it doesn't take me directly to where you are. So is there a series of steps I need to take to get to where you are in terms of the cube root? Yeah, in terms of it starting with the cube root, it has to have 4 terms, right?
When you go to Wolfram Alpha?
Yeah, if I go to wolframalpha.com, right, it just
Yeah,
takes me to a blank, it just takes me a regular page, and I think I'm supposed to click on algebra and then click on that other stuff, right?
Oh, it doesn't go here?
No.
Huh.
And then I think I'm supposed to go to algebra, polynomials,
Oh,
and
even when you just type it straight from there, like from the main page, it works because I didn't click anything. I just like did it and it still worked.
Oh, really?
Yeah.
Oh, okay. All right. Never mind then.
Okay, yeah, I'm not, yeah, when I go, I do see there's like this, algebra,
Yeah.
you know, but that leads you to like a bunch of like samples that actually makes it even more confusing. They're kind of just showing us all the things you can type. But if
Okay.
see up here, even if you're in that page, at the very, very top, there's a thing that you can just type into there.
Wait, sorry, I'm not seeing you I'm
Oh.
not seeing the Zoom for whatever reason right now. Give me 1 second. I don't know what just happened. Okay, what's hidden? Can you do that again? Sorry.
Yeah. So if you were over here and you saw like algebra and you clicked on it, even there at the very top, there's a little search bar. And if you were to type it into there, simplify, you know, simplify x minus 2 squared, whatever, it would do it for you, you see?
Okay, got it. All right.
Okay, so now let's look at what the homework is. The homework is 5 questions. Question 1, 2, and 3 are to use the Cardano formula to solve these depressed cubics. Some of those might simplify, and if they could, you should. Let me write down. If
they simplify, sorry, I have a question. And if they simplify into an integer and you get the answer for x, then how would you go about then for the y?
Oh, if there's an x, there is no y.
Okay.
The y is only if you had to, if the equation is already depressed cubic, then you don't have to do that other step where you convert it into the other equation.
Okay, thank you.
Now, number 4 just says it's a convert. You don't actually have to solve it. I just want to see, do you know what to replace x with and how to simplify? So that only takes a few seconds.
So where should our simplification for that one and equals a y cube equals something? You just need 3 terms at the end?
That's right.
Okay, yeah, I see. Okay, got it. Okay.
If you do the right thing, the y, I'm even going to write
cancel it out.
I'm even going to go like that.
Yeah, okay.
And then the 5th question is to do the entire process. So you're going to convert, solve for y with a depressed cubic, and then do a plus or a minus, whatever it is you need to do to convert the y answer into the x answer. So this whole homework assignment should only take about 30 to 45 minutes. Maybe less if you're feeling really comfortable with it. Now, I did make a video which explains, if you care to know what the form, if you feel like, okay, I'm really dying to know where that formula came from, the whole like Cardano formula, you can watch that as enrichment, but it's not like, it's there for you, but I'm happy if you're able to answer these 5 questions. Because in the history of math, that formula is one of the most important and mysterious formulas ever made, just that it took so many thousands of years for someone to figure it out. So I wanted you to like learn what it was, but it's not so important that you understand the derivation of it. Okay, so that's going to be it for today.
Can I ask
Tomorrow,
a question?
yes.
So,
Yeah.
I'm sorry, I'm just looking at all the various notes. So when you say the Cardano formula, which one?